Hello friends, today we are gonna do an exercise about depth first search. What is DFS? What is depth first search? In my words, depth first search is exploring a labyrinth with pseudocode, exploring a way from root to other nodes, a labyrinth, okay? With the Chat-GPT's words, exploring and visiting all the vertices of a graph in a depthward motion before backtracking. What it means? It means you start from the root to depth, okay? Then, before the backtracking, you should explore as far as possible along each branch before backtracking. With an example, there is a good uh, binary tree like that. With doing DFS to this binary tree, we are starting from the root. I mean 1. You are coming to 1. 1 is now in progress, so color it to dark, and you should continue to other paths. If it has paths, continue with one of them. I'm gonna continue with 2, okay? Now 2 is in progress, color it's dark, and if it has paths, continue to paths. Now I'm at 4, dark to 4, and if it has paths, no it doesn't, so turn to 2. As far as possible I go, depth, and there is no more path, turn to 2, okay? Now 2 is already dark. If there is more way, go with this one. So there is 5, go to 5. 5 is dark now, turn to 2, turn to 1, and 1 has one more path. Continue at 3 with coloring dark. Then our result seems like that, okay? Let's take an example and you'll understand more clear. Without solution. Here's our question. What it says? There's an undirected graph right there that first search. What it says here, I don't know. I don't really care about an input. Ah, okay, a graph. There's a linked list here. It could be a matrix too, but they choose to show a linked list, okay? Here is our graph, and it starts from 1, and result should be that first search, and it wants a list like that. You should create a list. Okay, I'm gonna try to write a pseudocode. My pseudocode. We should create a function now. Let's create a function like dfs, and we should use some variables like our graph, our nodes, and we should create a list. And what anymore? Is there anything else? Yes. There should be a boolean like is visited. Yes, there are variables. In our function, what we should do? There should be a base case like if list length of list equals 0. No, it's not gonna work. Anyway, let's continue with our node. Is visited node should be true. What are we gonna do? Here I said when we go to the one, we should color it dark. It was orange, it was false, and I come here, it should be true. It's gonna be dark, it should true. Okay, so I should mark is like dark. Dark is true, orange is false. You can think like that. Make it true, and if it has paths, how can we write it? For neighbors in graphs node, if what can we write? If is visited neighbor equals false, we should do that first search to neighbor. That first search to neighbor. How can we write it? Again, graph. Now, not node, we should use neighbor. And list and is visited. After that, what should we do? We should write something here, I think. We should add node to list, I think. Can we do? Let me try to write it like list dot add node. Okay, this is our that first search. It's a recursive function. After this recursive function, we should write something like here. What can we write? Maybe we can write node equals 1 and result equals list, then print list. I'm not sure if it's a good pseudocode. In my pseudocode, I said I should create a function like that. That for search, it has variables graph, like this graph, node, like this node, a list, like this list, and is visited if our node is visited or not. Then, if our node, not if, I get my node to this function, and this function makes my node true. Now our start node is true, and I should add this to my list here. I add 1 here, and then continue with neighbors. For neighbors in nodes graph, for example, 1's neighbors 2 and 3. Okay, if is visited neighbor is visited 2 or is visited 3, okay, is false, return to recursively that first search for the neighbor. Okay, and then here is again list is visited, etc., etc., and our list is gonna create it with this pseudocode, and here I'm signing my node to 1. I'm signing my result list, and I want to print list, but I should here I should call it again, I think. Should I? Let me call it again. Depth first. Search for graph node, which is 1. Lists and is listed. Here is here's my function, and here I'm gonna call my function back. Let's see the results. Okay, there is some corrections. It's something good. Append. For Python, we are not using add, we are using append. In pseudocode, I think it doesn't matter. When checking for equality, use two equaling sign. Okay. These are not about depth first search. These are about coding things. Okay. It's not important things. They are not important things. My grammar is not good. Is there anything else? Fix the variable name for neighbor in. Okay, I write here neighbors and neighbor, but it says you should use neighbor and call the neighbor. Okay. Result list. Here result list. Here result list. It's not important. It's the name of variable. It can be list or result list. The how can I say it? Maybe it's Chat-GPT did it result list, because list could be a key code. Okay, the list is the really general word, so Chat-GPT prefers to make it result list. Double equality for comparisons. Then to initialize, this is a dictionary. My base case, while I'm trying to write something here, I couldn't create a base case. You see that? In my pseudocode, I should create a base case before doing my steps. This is our base case. Then this is my base case. This is my boolean. Is this firstly should be false firstly. This can be also this could be a base case again. And that's that. Thanks for listening my video. For my English, I apologize, I'm not really good at it. And see you at other videos.